if we have the two vectors are perpendicular to each other, this is the vector A and this vector B. So theta between them is equal to 90 degrees. Then you know cosine theta equal to cosine 90 degrees is equal to 0. So this just implies you have the A dot B over the magnitude of A times the magnitude of B equal to 0. This implies A dot B equal to 0. Now, if the A dot B equal to 0, this just implies cosine theta equal to this A dot B over magnitude of A times magnitude of B equal to 0. And since the theta is between the 0 and 180, so there is only one angle for which the cosine is equal to 0. So that is the theta equal to 90 degrees. So from here we know vector A is perpendicular to vector B if and only if their inner product, their dot product, is equal to 0. So this is the one special case about the angle between these two vectors. Now let's look at another special case. Now suppose this time vector A is parallel to vector B. Then either you have the theta equal to 0 or you have theta equal to 180 degrees, right? So if the theta is equal to 0, you have the cosine 0 degrees is equal to 1. If the theta is equal to 180 degrees, then you have the cosine 180 degrees is equal to -1. So this just to see A is parallel to vector B if and only if cosine theta is equal to either +1 or -1. And let's first look at the 48, and we try to find the angle between these two vectors, and we'll go back to the 54. So page 612, problem 48, and we have these two vectors. A is equal to 2, 3. Vector B is equal to 1, 5. To find the angle between these two vectors, let's use the formula cosine theta equal to A dot B over the magnitude of A times the magnitude of B. So let's get the dot product of these two vectors. You have 2 times 1 plus 3 times 5, right? Then for the magnitude of A, 2 square plus 3 square, and then take the square root. For the magnitude of B, you have the square root of 1 square plus 5 square. And then you simplify, you get 17 over 13 times root of 2. Okay. So now you can use the calculator to do this computation. Okay. So you can rationalize this denominator by multiplying both the numerator and denominator by root of 2. You have the 13 times 2, 26. And then the numerator is the 17 times root of 2. Now let's go to the problem 54. We need to determine whether this pair of the vectors are parallel, perpendicular, or neither. Actually, when two vectors are parallel, A parallel B, you must have the one vector equal to the scalar multiple of another vector. So that means vector A is equal to a k times vector B for some k in the set of real numbers. So if you can express one vector as a multiple of another vector, then this just means these two vectors are parallel.